A celestial being in pursuit. Recently, NASA has located a strange item is hurtling through space at 1.6 million kmph, which is so fast that it could shoot into intergalactic space and escape the Milky Way's gravity. But what kind of galactic speedy is this? Gonzalez goes into detail on how a celestial body might accelerate to such a high level and how it was initially found. On the one hand, are you familiar with NASA's Backyard Worlds project? This research project is looking for unidentified brown dwarfs and stars near the Sun in the Solar System's backyard. On the other hand, it is searching for the fictitious Planet 9, which is supposedly hidden deep in the Kuiper Belt. However, what kind of academic background is required to participate in this thrilling galactic hunt? None at all. Backyard Worlds is a NASA-funded citizen science project that is primarily operated by volunteers. They are not required to possess any prior knowledge of astronomy. All they need to demonstrate is that they have completed a tutorial and viewed the fascinating objects that have already been added to the star charts. This demonstrates that amateur discoveries do not have to be hidden behind professional ones. The community search was made public in February 2017, and it only took 4 months for it to land its first direct hit, a brown dwarf located 111 light-years away. Celestial bodies that hold a unique position are known as brown dwarfs. We now know that brown dwarfs are anything but rare in space, and Backyard World participants have managed to locate over 4,000 of these celestial bodies. Additionally, a resourceful amateur astronomer discovered the oldest and coldest known white dwarf with a dust disk. However, in August of this year, NASA announced that we now know of the existence of an object in the Milky Way that is traveling at an incredible speed of 1.6 million kmph. However, what leads to this insane speed, and how do you even track down such a fast celestial body? This is a breathtaking discovery. The cornerstone of the Cosmic Aeonomus Space Telescope analyzed the sky in the mid-infrared range from 2011 to 2024 as part of the NASA Mission Wide Field Infrared Survey Explorer, or WISE for short. The mission was reactivated in 2013 under the name NEOWISE and ended on August 8, 2024. A while back, longtime Backyard World participant Martin Katnick finally noticed the WISE images. Amateur astronomers Thomas P. Bickle and Dan Castledon had discovered a dim, rapidly moving object with the scientific designation QUISE JQ1149. NASA describes Katnick, who happens to reside in Nuremberg, as saying that he was astounded at what was happening on his screen when he saw the WISE photographs. I can't describe the excitement when I first saw how fast it was moving. I was convinced that it must have already been reported, but as we now know, this was not the case, and after the clues from the Backyard Worlds community were received by NASA, following up observations with several ground-based telescopes were to confirm the exciting discovery. And so it was that the citizen scientists ultimately became co-authors of an official research study published in the astrophysical journal Letters, as already mentioned, the Cosmic Rabbit's Foot, with its astonishing speed, is currently also taking flight from our local Milky Way, but the bottom line is that it is by no means just the high speed that makes size J1 1249 so extraordinary. Airy, there is also its mass, which is so small that classifying it as a celestial body is complicated to say the least. And in the absence of reliable facts, researchers must therefore delve into the world of theories. It is therefore conceivable that we are dealing with a low-mass star here, provided it is not constantly fusing hydrogen in its core. It could also be classified as a brown dwarf. However, if this is indeed the case, the celestial body would become an astronomical exception. This is because, although the object is undoubtedly not entering the iron on its journey through space, data obtained with the Keck Observatory has shown that it actually contains much less iron and other metals than would be expected for stars and brown dwarfs, according to NASA. This is because we are aware of no other brown dwarf that is about to turn its back on its home galaxy. Unsurprisingly, experts can only speculate as to why the object is moving so quickly. One theory is that CIJ 1149 once formed a binary star system with a white dwarf, but the white dwarf may have taken so much material from its companion that it exploded as a supernova, literally throwing its stellar companion away from it. This unusual composition suggests that the celestial body is extremely old and may even have been one of the first generations of stars in the Milky Way. It is possible that the complex dynamics of this three-body interaction could launch a star out of the globular cluster. The bottom line is that it is now up to the experts to determine which of the two possibilities is more likely. To do this, the scientists will soon take a closer look at the nature of size J124 and hopefully soon be able to say with absolute certainty what turned the mysterious object into a cosmic object. According to theory, the later Speedy Gonzales was originally at home in a closely connected star cluster, a so-called globular cluster. Ultimately, the object may have made an unexpectedly rapid descent into the depths of space in this scenario. Take the lead. Given the speed just demonstrated, one might wonder if Foot, the Milky Way's fastest star, could go any faster. The answer is yes, and this is significant because while size J1-1249 travels at a respectable 444 km/s, it is merely a lame snail in comparison to the star S471, which moves at an incredible but real monkey speed of 24,000 km/s, or 4 million kmph, which is equivalent to up to 8% of the speed of light. The celestial body's ability to reach this speed is again made possible by its unique position as the Milky Way's fastest known star, S471, orbits our central black hole. Sagittarius, A star, and the stellar speed miracle takes just 7.6 years to completely orbit the mass monster. In detail, the discovery of S471 can be traced back to the research team led by Florian Pisker from the University of Cologne they had combed through the observation data of two spectrographs at the Very Large Telescope of the European Southern Observatory ESO and traced the orbit and speed of several faint stars the experts had previously identified. S2, an unusually bright star, in the vicinity of our central black hole, and while S2 was subsequently used to put Einstein's predictions on the gravitational redshift and the so-called Schwarzschild precession to the test, it also became the fast known star in our home galaxy. But while S2 still takes 6 years to complete an orbit, S471 accomplishes this feat more than twice as fast. However, the new record holder does not maintain a consistently high speed. Its average orbital speed is around 0.5% of the speed of light, but it only reaches its maximum speed of almost 8% in the immediate vicinity of the black hole, and experts actually assume that we could be dealing with a so-called squeeze, are here, in other words, a class of star that so far only exists in theory on paper, squeeze RS orbit. They're supermassive black holes in extremely eccentric orbits so that they are strongly heated by the tidal forces of the black holes as they approach before they cool down again in the distance. And indeed, spectral investigations have shown that the thermometer on S471 climbs to a good 10,000 Kelvin or 9700 DC. For comparison, the surface temperature of the Sun is around 5,272 Kelvin or 5,500 DC. However, the researchers also assume that the strong tidal forces also cause extreme bursts of radiation in such stars, and if S471 is confirmed as a squeeze, or in the course of further observations, it would be the first known object to bring this hypothetical class of stars from theory to reality, at the same time the discovery of S471. And 4 other faint stars in the center of the Milky Way also indicates that a whole population of previously undiscovered stars could still be dormant in the extreme zone around the black hole, and together with the stars already detected in the so-called S-cluster, the orbits of the new discoveries form 2 disks that are almost edge-o-edge at a 45 degrees angle to the main plane of the Milky Way. What this unusual arrangement is all about, however, is just as unclear as the question of how stars can even form in the vicinity of a black hole without being torn apart by its gravitational effect during their formation. However, as young protostars with dust cocoons have already been found in the vicinity of Sagittarius. We would love to prevent you from ever missing another video from us, so please give us a thumbs up. According to a star scientist, there may be a second, much smaller black hole dormant in the Milky Way that would counteract the gravitational pull of its more massive counterpart and save the stellar birth clouds from annihilation. And to remain updated going forward, subscribe now. We'll see you soon.